We are working through numerical summaries, chapter 2. Well, we just did an intro last time, so it's means and medians. Remember, interquartile range and all that good stuff, and that's great. I want to focus today on 5-figure summaries, getting range, median, and interquartile range. The good news is that for half of these questions, the 5-figure summary will be done for you, so you only need to use the data that's in them to find these. We've touched on this a little bit. How do you find outliers using interquartile range? You remember that upper fence and lower fence? And then we're going to show you how, when you do box plots, if there's an outlier, how do you cope with an outlier, right? And that's something I want to get done. And if we might or might not get to this because there's not many questions on it, but we might get to using the dot plot and histograms, but I'm not so sure I'll get that far. So let's give you an example of finding a 5-figure summary, right, from scratch. That'll be my first one. And then variations on telling you things and how you would get them. So I'm going to start with 1, 3, 3, 7, 9, 11, 15, 16, 19, 21, 24, 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. We normally in statistics say n equals 12. That tells you how many numbers there are. And we are going to create a 5-figure summary. So that's the minimum, Q1, I'll call it the median, Q3, and finally the maximum. So from this set of data, I'm going to get a 5-figure summary. Once that's done, I'm going to find the range in the interquartile range. Once I've done that, we'll draw a box plot, right? So we'll do the whole thing by hand. Now, since there are 12 numbers, would you agree half of 12 is 6? So the 6th number along is where the median should live. Well, when there's an even number of numbers, watch what happens. 1, 2, 3, 4, 5, 6. But 1, 2, 3, 4, 5, 6. And I think someone mentioned this yesterday. What do you do when there's 2 numbers in the middle? And we answered that, didn't we?
Add them and half it.
Aye, you nailed it. Add them and half it. So that's 13, which came out as a nice number. So are you comfortable about how to find the median? Right. If it's an odd number like 7 numbers or 9 numbers, can't you get the middle? If you really wanted to, couldn't you just plug into the calculator and get all 5 figures, right? 5-figure summary from your calculator. We showed you that yesterday. If you forget about that, can't you just go back and zoom through the video till it gets to that bit and then just pause it and watch it? Now, I should have put in the 2 freebies. Shouldn't I put in the minimum and the maximum? Right. Now, there are 2 numbers in the middle. That's changing the rules a little bit. I want you to imagine that there is an invisible middle wall going between those 2 numbers. What you've now done is split the data into 6 small numbers and 6 bigger numbers. You see that? And isn't Q1 the middle of the little numbers? So let's see what happens there. Oh, wait a minute. There are 6 numbers here, aren't there? You see them? 1, 2, 3, 4, 5, 6 numbers. So won't the middle be there? So there's 2 numbers in the middle again, but that's add them and half it, right, Cody? So the answer is 5. Does that make sense? Right. So Q1 is going to be 5. I'm trying to pick this one to have as many things wrong with it as it can, right? Most of the time you don't get anywhere near as much awkwardness. Okay, here is the top. There are 6 numbers there. Tell me the 2 guys in the middle this time. Which 2 numbers are in the middle of that list?
1921.
Great. And so add them together, half it, blah, blah, you get 20. Now, isn't it okay to get 15.5 and 7.5? Because sometimes that's what you get. So don't think they need to be whole numbers. They don't. And that's what we call a 5-figure summary. Right? And I did it by hand because I think it's good to know how to do it by hand so that when you do it in a calculator, you're just doing it because it's quicker, right? You're not doing it because you don't know how to do it. You're doing it because it's quicker. Right, now, they ask us for the range. And the range is the difference between the biggest and the smallest. So in this case, the range would be 29. Comfortable with that answer? This is only for completeness. Isn't the median just, I know what the median is, I don't need to calculate it, it's 13. And the interquartile range, right? Can anybody remember the formula for the interquartile range?
Don't you multiply the median
No,
by
multiply.
1.5?
I know what you're talking about there. What you're telling me right now is how to find outliers, Randy.
Q3 minus Q1.
Yeah. And what you just said will be done in a question where you're trying to find outliers. But for the interquartile range, it's Q3 take away Q1, which in this case is 20 take away 5. And so the answer is 15. So if I have a 5-figure summary, I can get the interquartile range, I can definitely get the median, and I can calculate the range. Are you comfortable with how to find those 3 guys once you know this thing here, right? Okay. Next thing I'm going to do is check or test for outliers. As I scan through the numbers, the outliers live at the edges, right? So that 30 might be an outlier and that 1 might be an outlier. My gut feeling is no way in Hades is that an outlier. Would you agree? It's so close to 3, it ain't going to happen. I don't know for sure, but I think 30 probably isn't going to be an outlier, but I have been proved wrong. So we need to have our test, right? Remember the test, the thing Brandy was talking about, right? How do we calculate these? Now, since I'm only really interested in this one, I'm not even going to do it for the small side. So we have a guy called the upper fence. And I'll now tell you another name for it. It's called the upper boundary as well. And the formula for calculating it is Q3 add 1.5 times the interquartile range. So in this case, Q3 is 20 plus 1.5 times 15. And so that's what, 20, I'll do it in one go. So 20 add 1.5 times 15. I get the answer is 42.5. So the rule is, don't you have to be bigger than the upper fence to qualify as an outlier? Great. Now, is 30 an outlier? No. I didn't think it was, but you know, as I said, I've been proved wrong. Sometimes you get surprised and you say, whoa, I didn't think that was that strange that it's an outlier, but it is. So I'm now going to move on to, again, doing it by hand, although later on you'll probably get Salt to do it because it's quicker. I'm going to draw a box plot of this data, right? So the smallest number is 1, but it makes sense just to start at 0, right? And the biggest number is 30. So that's going to be 10, that's going to be 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, Obviously, square paper would be a much better idea. And the minimum is 1. And you put a little mark there at 1. Q1 is 5. 1, 2, 3, 4. And you draw a big long line at 5. The median is 13, which is about here. And you draw a big long line again. Q3 is 20. So you do another big long line here. And then the maximum is 30, and you do a little line. And these two guys get joined up. And there's your box. If you call it a box and whiskers, which I would call it, or a box plot as they do, we have now drawn it. So far, so good. Right. Now, that's that question pretty much done, haven't we? From scratch, found the 5-figure summary. We found the range, the median, and the interquartile range. We've checked for outliers. In this case, there weren't any. And we have drawn a box plot. That's pretty much from start to finish, almost everything you could do with that data, right? As far as 5-figure summary and box plot is concerned, right? Now,
I got a question.
yes.
Okay, for the homework, it's kind of like that, but it's asked for the, because it's 63 college men were asked about their ideal weight, 5-number summary of their responses. And it says about what percent of the men gave a response that falls in the interval of 145 to 202.
Oh, okay. So let me do some of those questions on this diagram, right? So can we pretend this is the ages of people in some family or whatever, right? Or some club, whatever. If I said to you, what percentage of the people are in the range 20 to 30, right? That's from there to there. The answer is 25%. Because 25% of the data is between here and here, 25 more from here to here, 25 more from here to here, and finally 25 from here to here. Now, although the intervals are bigger, inside that interval is where 25% of each of the numbers lie. Do you see why these are called Q1, 2, 3? Why it's quartiles? You see it breaks the data into 4 major chunks, right? So if I went and said to you, what percentage of people are aged 5 to 20, right? There's 5 and there's 20. What percentage of the data is from here to here?
50.
Agreed. If I went and said to you, what age is the bottom 25%, right? So what age range is the bottom 25%? Wouldn't the answer be from 1 to 5? That's the bottom 25%. What age are the top 25% in? Wouldn't they be in their age range 20 to 30? What age is the top half? 13 to 30. What age is the youngest half? 1 to 13. Do you see how you can break it up and ask it in different ways, but still in chunks of 25%? Now, if they went and said to you, what percentage of the people were older than 23, right? I would have to go here and say there's 12 people, 2 of them are older than 23, and when I just do 2 divided by 12 on my calculator, right? I couldn't get it from here. But as long as the numbers they're talking about are 1, 5, 13, 20, and 30, right? As long as they're in the 5-figure summary, can't I get the answer by just realizing it's versions of 25% being added together? Does that answer your question, Cody? Right.
Yeah.
So that is a nice version of that same situation. I'm now going to do a calculator version with a deliberate outlier. Fingers crossed. I'll definitely make it an outlier by making it ridiculous, right? So I'm going to just pick some numbers: 1, 3, 7, 17, 21, 23, and 82. And I'm deliberately making it a small data set, but it could be huge. You could do it the same way. But this time, I'm going to get my 5-figure summary by using the calculator, which is a bit quicker. And sometimes you're going to use the calculator because when you do WebAssign, they don't always give you a sort button, right? So we have to kind of work with that. I think the next one I'll do is I'll go and look if there's a sort button question. So we went through this last time. Can anybody remember the first button to press to get this data into my TI-84 so I can start doing 5-figure summaries?
Is it stat?
That,
You nailed it. It's start. So hit the start and option 1. And of course, there are going to be numbers from previous questions. So I just hit delete until they all go away. And I've picked this as a very small data set. So 1, 3, 7, 17, 21, 23, and finally 82. Now, just based on the raw data, do you think 82 is going to be an outlier? Because God, I hope it is, because I tried to make it one. But can you tell, looking at the data, it's extremely different from the next number, right? So my fingers are crossed that I did enough here. Right, so I've done the data, it's in. What button do I press now to get the 5-figure summary? I have to press a button. Any takers?
Is it stats again?
It is. Only this time, you don't go back into edit, you move over to calc. And the choice is one variable starts, number 1. And then you tell it the data is in L1 by pressing blue button 1, and then you do enter. And you skip by all the things that you don't need because I want a 5-figure summary, and I have got it. And here they go. The minimum was 1. Q1 was 3. The median was 17. Q3 is 23. And the maximum number was 82. Right. Are you comfortable about how you could find a 5-figure summary from a list of data using your TI-84? Now, if you don't have a TI-84, you can still borrow one from the college. Send an email to Cheryl Phillips. So it'll be C, won't it be CPHILLIPS at olympic.edu, and say that you would like to borrow a calculator, a TI-84, and she will tell you come at 2 o'clock and pick it up at the window or something, right? Or come into my office, which is in the Mesh building. So, and it's free. You get a loaner and you give it back at the end of the quarter. And that way you can do what I'm doing. Right, now back to this fella. I want to calculate the range. Won't that be 82 take away 1, which is 81? The median was basically just 17, and the inter-quartile range is 23 take away 3 equals 20. Are you happy about how from a 5-figure summary you can answer that question? And you will, the way that WebAssign does it is it gives you 4 pictures. One of them will be my guy here, right? So in this case, it starts at 1 again, so I would probably start at 0, and hold that thought. I haven't tested for outliers yet, right? And I want to test because I'm 99.9% sure 82 is an outlier, and I want to show you how you deal with outliers when you draw box plots. So here we go. The upper fence or upper boundary is going to be Q3 add 1.5 inter-quartile range. So it's going to be 23 add 1.5 times 20, which ends up being 53. Good. Would you agree that 82 is bigger than 53? And when you are bigger than a boundary, you're an outlier. Now, if I did the lower boundary, which would be Q1, take away 1.5 inter-quartile ranges, then you have to be smaller than the lower boundary to be an outlier, right? So you've got two extremes, bigger than the upper boundary or smaller than the lower boundary. Now, when you have identified an outlier, you can change the way in which you draw your box plot. I know I'm going to need 82, so here is 82. And now that I've done that, can I start again, because it's too near the top. I want to do a cleaner one than that, right? So I'll do it over here. So I'm going to start at 0. I'm going to pretend there's like 10, 20, 30, 40, 50, 60, 70, 80, and there's 82. So I'm going to use my 5-figure summary in a slightly different way. If you identify an outlier, you just put a dot there. Right? Just a dot. You then have to go and find the next number, 23. So 23 is about here. That's 23, about roughly. Q, the minimum is 1, which is about here. Q1 is 3, which is about here. Median is 17, which is about, oh, okay. Median is 17, is about here. And Q3 also happens to be 23, which is a bit annoying because it's on top of that guy. And so your guy looks like this. Can you pretend that I had a number like 27 here? So what you would typically get is a real, a finishing point. But just by having such a small data set, my Q3 ended up being the next number, which is very unlikely unless your data set is tiny. So that's one way to do it. The other way to do this is to go 0, 10, 20, and 30. And put in the 1 and the 3, and what was the other numbers? The 17 and the 23. And can we pretend there was another little guy there? And then just put a little note. 80 is an outlier. And do you notice that 80 doesn't make an appearance on this one? Now, there are advantages and disadvantages to both these methods. Salt is pretty dumb, which means it can only do that version. Human beings are a little bit cleverer. Would you agree? I know I made a right mess of that, but would you agree that this picture is just easier to see what's going on, right, than that one?
Okay, what's the other whiskers? I see the 23.
Yeah, I had to, if I planned this question better, there would have been, can we pretend there was a 25 in here as well?
Oh, sure, yeah.
Right. I just don't like box plots not to have a little tail on them. That's me being pernickety. Right, so the best way to do a box plot with an outlier is to remove it entirely and just do the box plot where instead of stopping at the maximum, you stop at the next number to the maximum, which typically won't be any of these other numbers, right? It will be its own value. And the reason for that, if you do an extreme, can you imagine that we had Bill Gates? Wouldn't that be the box plot for everybody in Washington's money, how much money they made? Would you see that that is not very helpful? Would you agree that's tiny and you can't see a damn thing? Wouldn't it make more sense to do a big blown up version and then just say Bill Gates and the 5 other people who've got ridiculous amounts of money are considered outliers and you'd leave them there? Right. So WebAssign will not do that, right? Salt will give you the weird, ugly one and you have to live with it. But human beings would remove the outlier, draw the box plot, and then just put, I'm calling him Bill Gates because I don't know how much money he's got. Right, Bill Gates is an outlier. Are we good with that technique? So it makes sense. Right. So that's how you deal with outliers. Are we cool? Right, I'm going to see if I can find the SALT version of that question. Just so that we can, you know, do the same thing, but let, you know, the SALT button take care of all the stuff for us. No SALT here. Oh, perfect. Great. Right, can I make that bigger? Probably I could. How do I make it bigger?
You control scroll it, should zoom in on the page.
Control.
Yeah,
And
control scroll.
not in mine, it's not. That's annoying. Okay, there's another way of doing it. If I make this any other number, when I return to this, it's got the little plus guy, and now I can make it bigger. There we go. So the one I'm going to do is for this list of data. Now, when I look at this list, you see that it's all jumbled up and there's 20 numbers. Would you agree that'd be very boring and time consuming to do it by hand? I could probably do it if I had to in the TI-84, but don't we just want you know, SALT to do it all for us? So I want to find the 5-figure summary of the cholesterol level of 20 people. So fingers crossed. Let me play safe here. Good. The reason I'm doing all this moving around is that there, if I don't, it overwrites my thing and I can't get back to the question. I have to do a new question. And of course, WebAssign randomizes it so you don't get the same numbers I got the first time. So that's really all that's about. Can you see the data that we had? It's all here. And if I click on there, can you see the original data underneath? Good. There we go. Now, descriptive statistics. Click on that first. And here is our 5-figure summary. Minimum, Q1, Q2, Q3 max. Wasn't that nice and quick? Right, it's all there. Hit descriptive statistics. Now, I'd like to see a box plot, and I'll warn you right now, WebAssign does its own version of box plots. The typical horizontal is what most people do, but they do vertical. So you're just going to have to live with that. I believe that's what I'm going to get. So charts and graphs, box plots. Oh, tell it a variable. There we go. There. Now, can you see that's what the box plot looks like? Maybe I should shrink this down now. Yeah, can you see how it's vertical? Now, if you want to know what it looks like, can you just turn your head to the side and look at it, right?
Which way do you turn your head?
You turn it so the small number is to the left. So you turn it to your left shoulder. Right. Hey, it's better than having to draw it by hand, okay? It's better than that. So we'll call that good. Now, I'm going to try a little experiment here, which may or may not work. So here it goes. I'm going to hit SALT again. And here is the data. Right. Now, the bigger, I'm going to pick one of these numbers and change it. And I'm going to make that 1800. Would you agree that that guy is now going to be an outlier, right? So I'm now going to ask it to graph it, right? And it's going to be a box plot. And I'm going to do the single variable cholesterol. And now can you see why you shouldn't do box plots with SALT? Can you see that the outlier is there? Do you see it's a little asterisk, a little red star, a little dot, whatever you want? But can you see the rest of the data is killed? right? You can't see it. That makes it very hard to understand what the box plot looks like. Would you agree it's crunched to nothingness? Do you think there's a way that we can fool WebAssign to drawing a box plot that looks nicer? More like the way a human being would do that box plot. I'm about to do that, right? You want to see it? Right. Go to the guy, I can't remember, oh, that. Go to the guy, see that guy there that used to be 1800, right? That guy there, kill him. Imagine he was 1800s, right? Imagine that was your outlier. Kill him. Right? Can I kill him again? Maybe I have to kill him twice. Kill him.
I think you have to hit the little trash can thing.
What do I have to hit?
Yes, that one.
Oh, are you sure? Yes, I am sure. I'm sure I killed that one. After about the fourth attempt, would you agree I finally killed 180? I'm not quite sure what I did wrong the first 3 times, but it's gone. Once you kill the outlier, you can just go to charts and graphs, do your box plot, and there you go. Do you see that you can now see what the thing looks like? And then you can put a little note underneath, 1800 was an outlier, right? And call it good. So far, so good. How to get a 5-figure summary by hand, how to do it with a TI-84, how to do it using SALT, how to do a box plot all 3 ways, and the adaptation that you need to use if you discover that one of your data points happens to be an outlier. Now I've forgotten what the question was. Oh, I don't have the answers anymore, but couldn't we write down the 5-figure summaries here? And wouldn't one of our pictures be this one? I have no idea which one it is, so I'm going to pretend I know. And it was that one, right? And so you just pick the picture that looks like it. Does that make sense? Right. You look, your guy's going to go that way. You turn your head on the side, you say, okay, it's long, medium, medium, short. Okay, long, medium, medium, short, you know, somewhere memorizing it or whatever, and then you come back and you do that. Or if you're like me, you can have 2 windows and you'd have one of them on the first window and that in the second, which kind of makes life so much easier. What you've then got in question 6 and question 7 is basically the same types of questions. But do you notice that they also have, is there an outlier? Oh, wait a minute, are you looking at the screen? Can you see what I'm saying? Okay,
Yeah.
so if you've got an outlier, aren't you going to have to scan through your data and say, is that minimum number, is that maximum number, does it look extremely different from the rest of the data? And then won't you use the upper boundary or the lower boundary test, you know, Q3 plus 1.5 IQRs, right? And see if it's too big. And if it is, if there are no outliers, then write none. I'm going to pretend I know the answer, which I don't, but I'm going to pretend that 213 was an outlier. And so I would put in that if it was, right? And if there were none, which definitely will harm, then I would just type in what they asked me, and they asked me to type in none, so that they know that you just didn't miss the box out. This set of data here is the weight of 9 men in a rowing thing, right? And I guess you have to know what a coxswain is. Is that how you pronounce it, coxswain? Yeah. You know that have you ever seen them? It's a weird sport that probably only 20 people in America even do. It's those long, narrow boats with a little guy in a megaphone going, 1, 2, 1, 2. You ever seen that? You only see it in the Olympics, right? That's the only time anybody would ever even think about watching it. Do you know the guy that's at the front that's got the little coxswain? Do you know that they deliberately pick the smallest person to do that job? Because they're not rowing, right? But they're adding weight. So obviously the less weight, the better. So if you were being asked this question, which is not as stupid as it looks now, which individual do you think it is? Shouldn't it be the lightest of everybody in this list? And I'm scanning really badly. I can find 108. Can you beat that? Okay, so when I click on this, one of them is 108. Right, and now you've answered the question. Okay. Now, here is a set of data. If you hit that guy, won't you be able to get medians, Q1s, Q2s, Q3s, interquartile range? Find out if there's anybody there. Oh, and isn't that nice? They even told you the formula. Do you see it? Which is cool. And there might be an outlier. If there was going to be an outlier, that is the smallest one. So that might be a candidate for the outlier. And this one here is the biggest one. That could be a candidate for the outlier. There might not be any. And then don't you hit, oh, let's do this one. You hit this guy. There's the data. If you want to get the 5-figure summary, you hit descriptor statistics. Right, there's a 5-figure summary. If you want to see what it looks like, you do that, and then you turn your head on the left shoulder, right, and one of those pictures looks like that guy. Well, it'd be one. I could tell you off the that. Let's pretend it's that one. Oh, now this one here is containing, God, how many? 46 years worth of data about the annual rainfall in one place. I would never do that by hand, right? No point. Don't you have to put the numbers in order for starters? And wouldn't you have to have a really big piece of paper if you wanted one line? I'm not even sure I want to do it in the TI-84 because isn't typing in 40 odd numbers just probably too much work? So aren't we glad it's got a salt button? Right, so you can do all of those questions. And there you go. Oh, they do have a little bit different at the end. The 5-figure nominal summary shows the median annual rainfall is this. The middle half of the data are between this number and that one. Right, I'm making these numbers up. Can you pretend that this is 52 and this number ends up being 62? The middle half of the data then is between 52 and 62 inches. Remember, they're breaking up into quarters. That's one of those questions. I think you were talking about something like that earlier, Cody, weren't you? Where they asked you top half, middle half, things like that.
7.
Oh, question 7. So this one here looks 9 does a similar thing, right? Now you're going to look at something a little bit different. This is 2 sets of data. So I guess I'm going to try my best to do a quick version, not a detailed version of what you've got here. Right, this set of data and this set of data, would you agree they're pretty small? So I could do them on my TI-84 calculator, and I'm just going to pretend that I did, because we don't have enough time for me to do it from start to finish. So in this question, you've got 2 groups, right? You've got group 1, which starts with the number 5, 33, and then it goes and does that stuff. And then you've got another one called group 2, and group 2 has 6 and 10, and then it does all that stuff. And in question A, you get a 5-figure summary of group 1. And then question B, you do the exact same thing for group 2. So I want you to imagine that I actually did that. And I'm just going to make up numbers, right? So you're going to pretend I took all this data, put it in my calculator, and I got the answer 5, 15, 20, 25, 33, right? Just for argument's sake, right? You imagine you could do that, right? All that data, this is your 5-figure summary. You do it for group 2 now, which is these numbers. And let's suppose that the answers I get this time And I got those numbers, right? Let's pretend that that's what I got. What we're now going to do is do a combined box plot. So you do one line, and where this pen is, you do the first one, group one, and where this pen is, you do the second one. Now, to be able to draw a box plot from each of these, you need to know what the smallest number is in both, it's 5, and you need to know the biggest is 33. So I'm going to go 0, 10, 20, 30, 40, right? That's plenty of numbers, right? Everything's going to fit in that range. I'll take group one, starts at 5. There's Q1, there's Q2, there's Q3, and it finishes at 33, which is about here. Are you comfortable about, I'll call it G1, how I did this 5-figure and made a box plot, right? You then take this one and you put it up here, say, a little bit further, 6, then you do 10, and you do 15, and then you do 20, and then you finish with 27. And obviously a lot neater than I would do it, isn't there, G2? Now, by having two box plots together, it makes it a lot easier to do compare and contrast. So let's just pretend that these are the costs of buying something, right? Right, all the different kind of things. So this is buying milk and this is buying cheese or something, who cares, right? When you look at the two groups, would you agree that they are different, right? Oh, let's do something to do with gasoline. Who knows, one day it's going to cost you $30 a gallon, especially with our government, right? So you got gasoline in Texas and you get gasoline in Alaska, right? Two places. So that's my story. Would you agree that the distribution of gasoline prices is different? Would you agree that group one typically is bigger numbers than group two? Would you agree that there's a lot more big numbers because most of this picture is to the right? Good. If you were looking at the typical number, wouldn't it be $20 a gallon compared to 15? Wouldn't that be 1 to 8 compare them? In this particular picture, there are no outliers, but if there were outliers, couldn't we say this guy has an outlier, that guy doesn't? We could do things like that. Can't you tell the minimum price is about the same, right? There's not a lot of difference, but isn't there a significant difference in the maximum price of gasoline? You could tell all sorts of kind of compare and contrast things like what makes Alaska different from Texas, right? That kind of competition. You can actually, and that's what I'm going to do, finish with here, talk about the shape. Remember symmetric, skewed left and skewed right? Remember those terms that we use with histograms? You can actually do them with box plots. If you get a box plot that looks like this, everything is basically balanced, right? The boxes are split in the middle. This side and that side are about the same length. That would be an example of symmetric data. Does that make sense that that's very symmetric looking, right? They call it normal, they call it bell-shaped. There's probably another name in there, I just can't remember it, right? There's lots of names for that shape. And here's the other two shapes. One of these two shapes is skewed to the left and the other one is skewed to the right. One of these is skewed to the left and the other one is skewed to the right. That's the name we typically use, right? Which one is skewed to the left? The top or the bottom? Agreed. And obviously that one's right. So if your data, your box plots have shapes that are very balanced, the data is probably symmetric, right? If you made a histogram, it would look like a hill, right? If it box plot looks like this, isn't there a lot of leftness to this shape? The box is big on the left, the tail is big on the left. And in this case, it's right skewed, right? The box is big and the tail is big. Of course, you sometimes get a shape that looks like this. And that has no name at all, because that's just basically random data and has no, you know, if you did a histogram of it, it wouldn't look like anything, right? It'd be up and down and, you know, like skyscraper silhouette of New York, right? There wouldn't be any discernible shape to the data, because it's okay to have no shape, right? It's okay not to have a name, right? Last name down for attendance, and bye-bye.